Hi there folks, it's Mr. Rennie Evans here and I'm going to be taking you through some winter FAB revision materials for higher applications of maths. So what we're going to be looking at here is we're going to be focusing in on the following topics, and these are based off of the feedback from the Block 1 assessments and also from kind of what we've been doing recently in terms of the statistics assessment and moving on into finance. So I'm going to give you three questions here, so the Venn diagrams, the expected value and the interest calculations that are all going to be done as written questions, and then I'm going to go onto RStudio and Excel to do the correlation and regression and then the savings account goal seek question. Okay, so there's a wee bit of something for everyone in there, and at the end of the video I'll be pointing out some places that you can go to get some additional resources to help you with your revision over the holidays. Okay, so first up, let's have a look at this Venn diagrams question here. So Venn diagrams have always been part of higher apps, but they have not been assessed until this school year. It's part of the material that has been added in additionally. Okay, so I think that there is a very good chance that there will be a Venn diagrams question that comes up in this year's SQA paper, and I think that that would maybe suggest that it would be something to have a look at before your FAB as well. So we can see here we've got a group of students who are asked what types of TV programs they watch out of a choice of comedy, reality and drama, and then we get given all of our information. Now we need to be really careful with a Venn diagram question that we want to basically start from the center of the diagram. So we want to start from in here and work our way out into all of the other sections. Okay, so that's where we want to go. Now, that means that in this list here, I'm actually going to start from the bottom and work my way up. So if I am told in a Venn diagram that there is part of that population who do not fit into any category, so 2 of them watch none of these programs, then remember that that 2 is just going to go outside the Venn diagram. Okay, so it's still going to be counted, but it is not going to fit into one of the categories. So 2 people watch nothing, 8 people watch all 3, so that's going to be our intersect of everything in the middle. 14 of them watch both drama and comedy. So what we need to start doing here is we need to identify where is that cross-section. So the drama and comedy cross-section is here. And within that kind of like oval, like eye shape that I've drawn there, the numbers need to add to 14. Okay, now that doesn't mean that I'm putting 14 in here, okay? That is definitely not what I'm going to be doing, okay? What I'm going to be doing instead, let me get rid of this shape as well, is I need to make sure that the number that when I add it to 8 that I've got in the middle, that they are going to sum together to give me 14, okay? Right, as you can see, I'm struggling to get this tab away, there we go. Okay, so what add 8 gives me 14? Well, that is going to be 6. So I get 6 in this intersection here. And that's how I'm going to deal with all of these bits here. Now remember, all the way throughout higher apps, you're allowed to use a calculator. So please make use of your calculator if you think that it's going to help you, okay? So for instance, the next one, 12 watch reality and drama. So that's going to be in, what section are we going? This section here, okay? So we're thinking 8 add what gives me 12, or I could just do 12 take away 8, and that's going to give me 4. Okay, and then in this top one here, 45 take away 8, and I'm just going to stick that in my calculator. Make sure that I get it right, 37. Because the last thing we want to do is make a wee arithmetic mistake and not get the mark. Okay, so there we go. There's all of our intersections done. Okay, so now we go into, from this section up here, 21 watch drama. Now that means that in this full circle here, all of the numbers need to add to 21. Okay, so what I would do is in my calculator, now obviously you can't see my calculator, but you'll be able to hear me pressing it. I'm going to take 21 who watch drama, so 21, and then I'm going to take away 6, take away 8, take away 4. Okay, and that'll tell me what needs to be left in there. That needs to be 3. Okay, right, hopefully that makes sense. Let's do the same thing for reality. So reality, this full circle, needs to add up to 55. So I'm going to do 55, take away 37, take away 8, take away 4. That's going to give me 6. So 6 people watch just reality. And then lastly, this section here needs to add up. Well, that circle wasn't as good. They need to add up to 60. So I'm going to do 60, take away 37, take away 6, take away 8. And I get 9 who watch just comedy. Okay, and that would be the end of the Venn diagram. So I am getting, let me see if I can show you. In this case, you're getting 1 mark for getting the 8 correct in the centre. You're getting 1 mark for the 2 placed outside. And then for every other value correct, that is your 3rd mark. Okay, so if you can remember these two steps that are the first two things that we did, starting from the bottom and putting in our 2 and our 8, you've already got 2 out of 3 marks for that question. So see, if you really can't remember how to do anything else with a Venn diagram, I know that you can get at least 2 marks there. Okay, let's move on into our next question then. And our next question is going to be our expected value and cost benefit analysis question. Now this is quite a long question, so we're going to just do it in like parts by part. Okay, so the first thing that we're looking at here is that we've got a TV production company and they are delivering a quiz show, and we're talking about the production being delayed. And if the production's delayed, then they are going to be charged £10,000. So we're going to start carrying out a cost benefit analysis here. So we're assuming that there's only 2 events that would cause a delay. So the first one of those being that a member of staff falls ill, there's a 0.3 probability of that. And that there will be an equipment failure, there is a 0.1 probability of that as well. Okay, so let's take that information and let's start making the expected value of costs that should be considered for the cost benefit analysis. Okay, now the first thing that we're going to do here is we're going to start off by making our tree diagram. Okay, and that's probably the best way for us to go here first. So let me just change this pen back over. Okay, so we're going to go for our tree diagram. We're going to say here that the probability of someone being ill, let's start with that. Okay, there is a 0.3 probability that would happen, which means that there's a 0.7 probability that they will not be ill. Okay, so that won't be an issue. Okay, next we're going to go for equipment failure. Okay, there is a 0.1 probability that will happen, which means that there is a 0.9 probability it won't. And again, let's just put it back in here, equipment failure. So we've checked both these branches. 0.1 that it will fail, or 0.9 that it won't fail. Okay, so the probability that someone is ill and there's an equipment failure, remember we just multiplied together the probability, so 0.3 times 0.1. Okay, the probability that someone is ill and the equipment is fine, so let's just say fine, that's going to be 0.3 times 0.9. The probability that someone is not ill, so they are well, and there is an equipment failure, is 0.7 times 0.1. And the probability that someone is well and the equipment is fine, which means that there wouldn't be a delay at all, is going to be 0.7 times 0.9. And what you'll find is that will probably give you your biggest number. So we've got 0.03, 0.27, 0.07, and 0.63. Again, use your calculator and make sure that you are getting that right. Okay, so the probability that there is a delay comes from all of these options here. So the probability of a delay is going to be equal to the sum of all of these parts here, which is going to be 0.03 plus 0.27 plus 0.07. Oops. That's going to give you a probability of 0.37, which means that our expected cost, I'm just going to do this up here just so that I'm not squeezing it in. So the expected value of costs that should be considered would be equal to 0.37 times by, and in this case that would be our penalty being appointed here or awarded. So the expected value of this is going to come out to be £3,700. Okay, so let's have a look at where our marks are going to come from here. In this case, the first mark that you're actually getting is you're getting a mark for calculating the probability of no issues occurring. So they've done it in a slightly different way without using a tree diagram. But basically from here, I reckon that you would get 2 marks essentially within your tree diagram. I'm just not 100% exactly where they would come from right now. I'm thinking my best estimate would be that you are going to get 1 mark for knowing to use a tree diagram, so setting up your tree diagram correctly here. and then interpreting your values out at the end here, okay, down to the point where you know that the delay is going to be 0.37, okay. I think that is where it would come from, but I will double check. I know some people with SQA, so I'll ask them and I will get back to you on that one. Your third mark is coming from doing your actual calculation here at the end, okay, so that's the 3 marks that you're getting for that question there, okay. So part B goes on to ask you to calculate the expected value of costs if control measure 1 is taken, okay. Now remember, what that means is that we are going to take the control measure here, so employ backup staff at a cost of £1,000, but that means now in our probabilities that there is no probability, if I go back to here, that a member of staff will fall ill. So it actually disregards that probability altogether. So there is now just a 0.1 probability that there will be an equipment failure, okay? And that's what we're going to base our kind of probability calculation on now, of us being charged the £10,000 penalty, okay? So in this case, we're taking control measure 1, which costs £1,000, and we are adding on the 0.1 probability of an equipment failure that would result in a charge of £10,000, okay? So that is going to be 1,000 times, or plus 0.1 times 10,000, so that's just 1,000 add 1,000. Someone is screaming outside if you can hear them. And that is going to be £2,000, okay? So the expected value of cost if control measure 1 is taken is £2,000. So we're already comparing that with £3,700. So that's already going to be cheaper to take control measure 1. Now, the next part of this question is that's only a 1 mark question, so it's just 1 mark for getting that £2,000 as your right answer. The last mark here says that the expected value of costs if control measure 2 is taken is £6,000. So you're not actually being given the calculation that you need to do there, okay? It's just saying it's £6,000 if you take control measure 2. Which control measures should be taken, okay? So is it one of them, is it both of them, or is it none of them, okay? Okay, so what we need to remember is if we've got no control measures, then the expected value is going to be £3,700. If we take measure 1, then that is going to be £2,000 is our expected value. Measure 2 is £6,000, okay? So we can already rule out measure 2 is not going to work for us, and measure 1 is still cheaper than using no control measures. So we just need to write a wee sentence, which control measure should be taken. We would say control measure 1 should be taken as it has the lowest expected cost. Okay, and that, just with your reason of it has the lowest expected cost, will get you 1 mark there. Okay, and that would be your cost benefit analysis question finished. Okay, so let's go on now and have a look at question 3. Question 3 is a capital and interest question here. So Zach deposits £500 into a bank account on the 1st of January, 2018, 2019 and 2020, and the bank pays interest into his account at the end of every year using the following annual effective rates. So we've got 3.3%, 2.4%, and then 1%, and he makes no withdrawals from this account. What would the balance in that account be at the end of 2020? Now, what I would do here is I would consider each of these deposits individually and think about what happens to each of them, okay? So the balance in his account, or what I would sometimes call his accumulated value, is going to be this first £500 that gets paid in on the 1st of January 2018. We get one that goes in on 2019, one that goes in 2020, and it just says the end of 2020, so we're going to assume that they all get to have a little bit of interest paid in on them, okay? So the one from 2018 is going to first experience a 3.3% interest rate, then a 2.4% interest rate, then a 1% interest rate, and then each following year we're just going to lob the latest one of those off, okay? So, or sorry, the earliest is maybe the better way to describe that. So the 2019 one never gets a 3.3% interest rate, but it does get the other two, and the one from 2020 just gets the 1% interest rate. Now, we're going to do this using our knowledge of multipliers. So for instance, 3.3%, if I increase by 3.3%, I would have to multiply by 1.033 and so on. Okay, so 1.024, 1.01. That should be a 1, not 0. Okay, so once I've got this, I can now start going in and doing my calculation. Okay, so for each of these payments, down here, I'm going to do £500 as my first payment times by 1.033. Now that's just for 1 year and it's an annual effective rate, so I don't need any powers on it. So 1 year at 3.3%, 1 year at 2.4%, and 1 year at 1%. Okay, plus the next one, which, like we've already said, only has the 2.4% and the 1%, plus the next one, which just has the 1%, okay? And all we're going to do is we're basically going to stick that full thing into our calculator. What I would encourage you to do is try and get it all to go into your calculator without you having to kind of take any steps in between, because what will happen if you take steps in between, you can hear me typing away, is if you start taking steps in between, you're going to start rounding your answer, which might bring some inaccuracy into your final answer. Okay, I'm not 100% where I'm going to cut off from the tannoy. Okay, so if you start rounding earlier, so if you put things into your calculator, press equals, and you start rounding, you're going to bring in some inaccuracy into your answer, and we want to avoid that as much as possible. So I can stick this full thing into the calculator. I get £1,556 and 30 pence, and that would be my final answer for that question. Okay. Now, there is a further part B in this question, but I have missed that out, that goes on to work with present value. Now, remember, present value would be an A-type question, and you should go on and double-check your notes and the videos around about present value to help you out with that as well, okay? But that would be your 3 marks just there. You're getting 1 mark for considering what has happened to payment number 1, 1 mark for considering what has happened for payment number 2, and then 1 mark for considering your final answer here. Okay, so moving on. Now we're going to go on to looking at a correlation and regression question. So what I'm going to do is I'm going to load up this onto RStudio, and we're going to work through this question together on there. Okay, so this question here, we are given a data file and we have a wee bit of a blurb about it. So it's blah, blah, blah. UK has a varied mix of renewable technologies and fuels, including biomass. The heat output of wood chips is used to generate energy, varies depending on moisture content. The data in the spreadsheet shows moisture content as a percentage and the associated heat outputs in kilowatts of various random samples of wood chip. And we're asked to make a scatter diagram, go on and make some comments about it, regression of the regression line, and then also to go on and do a prediction from that as well. Okay, so we're going to fling onto RStudio now. Hold on. So here I am going to, well, first of all, let's open an R script, make sure that we've always got that open, and I'm going to set my working directory, and I'm just going to where I have stored the files here. Okay, so first things first is I want to read in my data using the read CSV function, making sure that I copy the name exactly as it is given, and then I am going to attach this file. So if I just click here, you can see I've got my 2 values open here. Now, I am not 100% sure what keeps happening with this file. This is a couple of different times that I've tried to do this, and it keeps giving me really weird looking notation for this. Okay, you can see this weird eye at the start here. So we're going to just work with that just now, yeah, we'll see how we get on with it. So the first thing that I was asked to do in this question here, if I just bring the question back up to double check, is that we're asked to construct a scatter diagram for that data. Okay, so if we take us back over to here, just make sure that I'm seeing everything. We're going to use the plot function. Okay, so I'm going to use my X variable and then my Y variable. So I'm going to just see if I can trick it into giving me the I, but I might just need to, hold on. See if I can steal, this from here. We're going to be sneaky about it. See if I can get that to work. No. Oh, wait, there we go. There we are. Okay. Not too sure what it is that's causing that, but it is not going to be an issue for you in the prelim or in the SQA assessment. Okay, so I've got my two variables there. I need to remember my other important parts is I need to have my X label, which is going to be moisture content and percentage. That's what I was told in the question. And my Y label is going to be heat output, and I believe that was in kilowatts. Okay, other things that I need is a title, so making sure that I use the same notation given. So this is scatter plot of heat output on moisture content, and I just need my wee extra bits. I need my PCH, and I also need my color. This is where I always forget which one works, whether it's background or whether it's color. So let's try and run this one just now, and I think that that does the job. So we can see, pops up down here. I'll make it a wee bit bigger for you. Oops. There we go. That is the scatter plot that I am working with there. Okay, just struggling to get it on the page properly, but there we go. Okay, and you should hopefully be able to see as well, if I just make it a little bit smaller to fit in, that I have got my X and my Y label, I've got my heading, I've got everything is kind of correct going on in there. Okay, super. So let's close that off just now. Now, all I would do with this is I would, if I just open it back up again, you can see down here, I'm going to hit export, and I'm going to hit copy to clipboard, okay? And from there, I'm just going to press copy plot. Now, what I'm going to do is, this is the file here that you are given to paste into. So I'm just going to paste that there. Okay, so I've got my heat and moisture content. We could also use this paste button up here just to help you out. Okay, now part B, or part 2 of this question, I've taken it out of the question itself. It says make 2 comments about the scatter diagram, and those would be written parts, okay? But let's just squeeze that in here. So A part 2. 2 comments about the scatter plot. Well, what would I want to say about that scatter plot there? Well, one of the first things that I want to do is I want to try and describe the relationship that I see. Okay, so where am I looking? Okay, so I want to state that I have got a linear relationship, or even better, for 2 marks, we're going to say I've got a strong linear relationship. Okay. And what that's going to do is I'm going to get 1 mark for stating that I've got a linear relationship, and the second mark is for a strong, or saying that I've got a negative, and that might even be better, a strong negative linear relationship. Okay, and then see how much better we've made that answer. Okay, so 1 mark for linear relationship, 1 mark for either strong or negative, and we make it really, really strong if we say we've got a strong negative linear relationship. Okay, so that's my plot done there. Now I want to find the equation of the regression line of heat output. Okay, so I'm going to go back into our studio here, and let me again just make sure I'm still recording what I want to see. Okay, super. So in my regression, in this question here, I want to find the equation of the regression line. Now that is going to come from using the LM function, okay? And remember that in the LM function, I do Y, and then you do the kind of wavy hyphen, and then we're going to go on and do, I just want this again here, so I'm just going to copy this down so that it works, okay? And you can see out in my, I'm just going to copy these up from in the console, I get this output here, okay? So I know from that how to write my regression line. Now remember, your regression line is going to fall in the form of y equals mx plus c. We don't want to use y and x though. We are going to use whatever is on the y-axis. Now for us, on the y-axis, you can kind of see here, on the y-axis, I've got heat output. So we're going to say heat output is equal to, now this value here that falls under the variable name is our gradient. So that's going to be negative 0.057 blah, 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 times by the moisture content plus or minus whatever falls under intercept, okay? Because remember that plus c at the end of y equals mx plus c is our intercept, okay? So from there, that is how we would go about writing our regression line. Now I'm just going to copy all of this, now making sure that I get my output, and I'm going to paste it down here, okay? So that I can very clearly show whoever is marking it what my equation is. Okay, now my last part of this question says to estimate the heat output of wood chips with a moisture content of 35% and we want to interpret this by referring to the prediction interval. Okay, so I'm going to go back into RStudio now. Now you could do this part by hand, but I would prefer that we did it using the predict function. Okay, so we are going to predict, and this is one that I do need to make sure that I get the formula sheet up for, because it has a lot of wee fiddly bits to it. So, oops, see, I've even made a mistake already. Predict, and then we're going to put in the same formula that we used up here. So predict on that linear model or regression model. And remember these fiddly bits here. New data equals data.frame. X is going to be equal to 35 in this case, because our moisture content is on the x-axis, and we want to make a prediction for a value of 35 on the x-axis. And then we're going to go on, and the last part is just interval equals pred for predict. Okay, so what do I get out as my answer here? So we're going to run this. And, oops, what's happened there? Oh, I have made a wee mistake. I may be wanting to have to change this to the word moisture. I don't think that is usually what happens, unless I put my whole thing the wrong way around. Oh no, there we go. Okay, there we go. That was the only thing that I'd not done there. Here where I have my x, make sure you change that to whatever your variable name is on the x-axis. Okay, now, in your console, you're going to see something like this printed out. Okay, now, we just need to know how am I going to interpret this. Okay, so the fitted value, so here is 5.944. The lower and upper bounds are telling us where we are likely to have a solution. Okay, so let's just write up what we would say there. Okay, so it should still be part C. So the estimated heat output of wood chip with a moisture content of 35% is, now just be careful with how we're writing this. Let's just do it as one decimal place, 5.9 kilowatts. However, the true value is likely to be between 5.3 and 6.6 kilowatts, okay? And what I would also do, just to make sure that I give my marker as much info as possible, is I'm just going to copy this over from RStudio as well, okay? So that they can see that's what I got and that's what I've interpreted, so I know that I'm on the right kind of track, okay? And that's going to be it for this RStudio question, okay? So let's think about where the marks are coming from here. So we are getting, in the scatter plot, 1 mark for creating the correct scatter plot, and the second mark is coming from your titles and from your axes labels. We've already spoke about here in the description, 1 mark for linear relationship and 1 mark for strong negative. In part B, you're getting 1 mark really for just being able to get this output. So see, as long as you can do that in RStudio, the LM part, and then paste that into your Word document, then you're already getting 1 mark. And then using the correct labels, so heat output, moisture content, and writing it into a correct type of equation will get you the second mark. Okay, and in part C, your first mark is coming from really evidence that you've been able to fit this correctly. So this here would get you 1 mark, and then your sentence would get you a second mark. Okay, super. Right, so let's take ourselves now onto the Excel questions. Okay, folks, so part A of this question here is a savings account question. We are going to use Excel for it, but part A is actually just asking to do an interest calculation. So, Carol's received a gift of £2,500. She is considering to put it in a savings account that pays interest with an annual rate of 1.25%. Okay, how much interest would she earn if she invested this gift in her savings account for 34 months? Okay, so what we are thinking here is we're going to take, and it's just a wee accumulation again, the £2,500. We're going to multiply it by that annual effective rate of 1.25%. And how long is that going to go for? Well, if it's going to go for 34 months, that is 34 over 12. And that would give you your kind of fractional amount of a year that 34 months is equal to. We don't need to do anything else with it here other than just stick it into your calculator. 1.0125 to the power of 34 over 12. Okay, that's going to give you an answer of £2,586.56. Now, the actual question asks how much interest is that going to get. So the interest is going to be the accumulated value, take away the capital. Okay, and that will tell us that she would accumulate £86 and 56 pence over those months. Okay, and that is part A done. Now for part B, we've got a personal loan and she's initially borrowed £8,000 and we're repaying that for monthly repayments for 48 months, okay, and it's level repayments. Okay, and the interest is an annual effective rate of 4.9%, and we're being asked to go onto Excel and complete formulae and calculate the level monthly repayment amount and the final repayment amount. So if we're going to be asked about repayments, then that means that we're likely going to have to use goal seek. Okay, so let's go over to Excel and see what's going on with this question. Okay, so here we are for part B. We are in Excel now. Now, there's all these info boxes that are going on at the top, which usually tell us that there's something we need to do in here. We're being prompted here to calculate what our monthly effective interest rate is. So let's use a wee formula for that. In this case, we're going to do 1 plus our annual effective rate. Now, remember that although that says 4.9%, Excel knows that that could also be interpreted as 0.049, okay? So it knows that that could also be a decimal. So we don't need to stress about that, okay? So 1 plus our annual effective rate. To go from annual to monthly, we're raising it to the power of 1/12, and then we need to remember to subtract 1 for that initial plus 1 that we've used, okay? So putting that through, we get our monthly effective interest rate is 0.4. Okay, fine. Now, what are we doing in here? Well, let's start off putting in our initial loan amount, which was £8,000, and we're wanting to take this down. How many months did we say? 48? Yeah, super. Okay, so we're going to drag all this down for 48 months, okay? And what that should do, yep, it's working there. We drag this down, drag it down, drag it down, drag it down. There we go, okay? So I'm dragged down to my 48 months there. So I've got my template set up and I'm just going to start filling in things like my repayment, okay? Now, what I would do in here is that because we don't know what my monthly repayment's going to be, is I'm going to use a dummy value here and I'm going to make that £100. And what we're going to do in the repayment cell is that we are going to absolute reference using our dollar signs to the monthly repayment. And then I'm going to double click and that will drop fill that £100 all the way down, which means that whenever I change the value in here, it'll change the value in all of these other cells. Okay, so we're going to leave that be just now because that's going to be helpful when we get onto our goal seek section. Okay, now we're looking for the interest content of each repayment. Okay, so first of all, we're going to need to calculate how much interest has been accumulated so far. Okay, so we're going to take our value from the year before, or the month before in this case, and we're going to just multiply that by absolutely referencing to the monthly effective rate, okay? And that means there, if I drag that down, yes, we are going to, in this case, be times in by 0, so we'll get no entry, but you can see there that this is how much of the payment is just purely interest, okay? Now, my capital content of the repayment, that's going to be whatever part of the repayment is not interested. So that is always going to be kind of whatever's in the repayment column, take away whatever's in the interest column there, okay? And again, let's drop fill that down. Lastly, my loan outstanding is going to be whatever amount of the loan is remaining at the end of the previous month, subtract the capital content, so what I've actually been able to repay back from the loan so far. And I'll drag that down as well. Okay, super. Now, what we can see here is that when I get down to month 48, I've not actually repaid off that loan. So this is where I'm going to need to use goal seek. So we go into data, what if analysis, goal seek. We want to set this cell here to a value of 0, and that's going to depend on my repayment value. So I'm just going to scroll all the way up and I'm going to click on this cell here. And what you'll see is all the numbers will do a wee dance, okay? And they'll feel like they've got to the best answer, okay? So it thinks just now that the best monthly repayment is going to be £183.49. However, we are not finished. You can see what happens here is Excel will take that to quite a large number, with lots of decimal places, and we don't work with money to that many decimal places. So although it's rounded, Excel is thinking we need to pay off exactly £183 and 48.61543 blah 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 pence per month, which we can't do. So what we're going to do is, I prefer here to just truncate, so get rid of everything down to just the second decimal place and press enter. And you'll see what happens here is that when we get down to our final month, we'll have a little bit still to repay, okay? All I do here is we're going to add on, or if you're in the negative here, then you're going to take away. But in this case, we're in the positive, so we've still got 32 pence left to pay. So I'm just clicking on my final repayment cell at the end there and adding on 32 pence, and we get down to 0. Okay, so we've fully solved that question there. The monthly repayment is £183.48. And usually in more modern papers, you'll be given a cell here that says final repayment. And what I would do is I would just hit equals and refer to this cell here. It doesn't need to be an absolute reference because it's never going to change. But that just makes it super easy for your marker to see. Now remember, one thing that we should be doing when we are working with Excel questions is we should be printing them in 2 different manners. We will print it once in value view, so that is like this. And the other way we should be printing it is also in formula view. So what we're going to do is we are going to go to the data tool up here, and we are looking for one of the cells, and it says formula view. What one is it that I'm looking for here? Need to check this every single time that I go to use it because I always forget. Is it in data? Maybe I'm talking nonsense. It's in formulas. That would make sense that the show formulas is in the formula view. Okay, so once we're in here and you've got your final answer, you print it once or ask whoever is printing to print it once, and then we go to formulas and click on show formulas here. Okay, and it'll make it all look pretty like this, and that makes it really easy for your marker to go through and make sure that you've been able to do it correctly. Okay, and let's close that off again. Okay, so that's just a wee extra tidbit there. Now, I think that that is going to take us through to the end of everything that we're wanting to look at with you today. So let me just jump on to our final presentation section here. Okay, now let me just change this and you'll be able to see the full PowerPoint again. There we go. Ignore that. Just a wee roller coaster ride for you. There we go. Okay, so what are your next steps? Well, your next steps are going to be as follows. You have got the SQA past papers, including the specimen papers, on the SQA website, first and foremost. That is the best place for you to go and get the past papers because they have the 2022, the 2023, and a specimen paper set up for 2024, as well as 2 additional specimen papers. Now, some of those do have repeated questions in it, but the specimen paper for 2024 is particularly useful for you to see what the questions may look like. On YouTube, you'll be able to go to the Larbert Maths YouTube channel and you will find lots of videos that Mr. Young has made very kindly on using different elements of Excel and RStudio for helping you. And also the website Applying Maths as well, that is made by a teacher from up in Fife who is also part of the SQA Higher Apps team. And there's lots of additional materials that are available there, and you'll have seen that we've maybe used some of those before. Okay. In addition to this, please make use of the revision tasks that are posted on Google Classroom. Mr. Young and Mr. O'Reilly have done a fantastic job putting all of those together for us to work on, and all of the resources in there are really fantastic. So I would make sure that you went through and you've practiced all of those questions. And also, please use your feedback sheets as well. So that's like your Block 1 feedback, and make sure that you know what topics you need to be revising for yourself, what ones already stand out as something that you maybe need to do a bit more practice on, okay? Best of luck with all of your revision. I hope you have a fantastic rest of your holiday, and we'll see you when you are back in the building. Okay, thanks folks.